Okay, so in this video clip, I'm going to take a look at how you would implement pivot tables using Pandas and we're going to use the titanic3 dataset. And first of all, we need a dataset. It's going to be titanic3 dataset. The way I will bring in our data here is I will go into the content folder. So when we go to the content folder, when we look in there, there is some data, but it's not data related to titanic3. Okay, so nothing in there related to titanic3. I want to bring in titanic3 data. I'm going to read in this R package. So if we execute the magic R command and load in this line of code and then install the R package, make it available in our library here in our environment, and it's we're using Google Colab, and this is a Python notebook, right? And if I take a look at our data using base R, if I want to take a look at our titanic3 data set, we have 1,309 rows, in other words, passengers, and 14 variables. So if we wanted to figure out where we could write out this data set to, if I introduce in exclamation pwd, I get the working directory. And so if I write out the titanic3 dataset as a CSV file, write CSV, it will appear over here in the content folder. And that should happen relatively quickly. Okay, I can download that CSV file and it'll come into my downloads. Again, to understand what a pivot table is, a pivot table is a table that offers a kind of brief or concise summary of a more substantial table. So we have our database here, our spreadsheet, our titanic3 data set, and we would like to build a smaller table that might be able, in an insightful way, pull out key details. Most people would have seen this in Excel. So again, if I go back to our environment here where I just downloaded the titanic3 and just bring up our titanic3 data set, right? Most people are familiar with doing pivot tables here. Now you could do implement manually or just go with a recommended table. And for instance, we could look here at, doesn't matter, let's just take this one. And you can see here the number of passengers who boarded in Cherbourg was 100. And again, so it's in fact, it's the sum of parents and children who boarded in Cherbourg, Queenstown, and Southampton, right? And probably we could pull in some other table, something else, maybe survived or something like that. And we get a sense of, okay, some of us have survived would include all the passengers, not just the sum of the parents and children boarding. And I mean, we can add in the sex and so on so basically we can remove these or can add in and create additional. We can maybe put something here. We can say, okay, look, we're considering all or select just the females, and toggle through and pull out summaries, summarizing tables of the bigger data table. Okay, so that's Excel. It's very powerful, very insightful. We're going to do something similar here, but set it up in the Python notebook that we have here in Google Colab. So first thing I'm going to do is I'm going to import in a few libraries, NumPy, which will be important, Pandas, matplotlib for graphing, and then PLT style. So we're going to use ggplot as well, which is available in so the ggplot format is available for graphing in the matplotlib. We'll need to read in. So once we've loaded in the pandas, we can read in our titanic3 dataset from here. We can take a quick look. We can see an extra an extra column has been introduced here. We can get rid of that if we run drop column equal to unnamed. Then when we print off the next 10, you can see that this unnamed column is now gone. And maybe we have we don't need ticket, cabin, boater, body, so we can just drop it and use the pandas syntax for that, and take again another look at our data set, and you can see that now it's been slimmed down quite a bit. So what's now in our data set? We should have 1,309 entries, and with PClass survived, name, sex, age, sibling, spouse, parent, child, fare, embarked, and home destination. Okay, so we've slimmed it down from 14 to 10 columns here. And normally we would like maybe to get some kind of summary output. So for instance, we have male and female sex, and there's just 2 categories for survived, just 2 categories. Those 0 is drowned, 1 is survived. For class, 709, 323, first class, 277, and second class. Okay, and again, siblings, spouses, 6, there was 2, there was 9 that had 2, there was 4 that had 6 sibling spouses, 5 that had 6 sibling spouses, 3 that had 8 sibling spouses, and so on. So this is a nice summary of who embarked and so on. It's not, it's something that's quite arbitrary, and we're kind of getting everything now. We might note that for the when we look at the age here, quite a few of the ages are missing, right? So that's just one of the features here associated with the titanic3 dataset, that we have in excess of 240, 250, 260 ages missing. One way we could deal with that, but not a very nice way, but quick and just to expedite things, we can say just drop the missing values. And now when we look at our titanic3 dataset, it's now been slimmed down to 1,044 passengers and 10 columns. Okay, so we've done some manipulation here. Normally, though, if we were missing that number of ages, rather than throw out all our data, we would probably try to do something else and maybe do some feature engineering, but we're not going to get too preoccupied with that. Okay, let's get going down with this slimmed down data set. Then let's do a little bit of pivot tabling. And the Pandas offers a very nice syntax. It's quite logical. So a simple line of code like this says, look, create an object called table. Use this function that's available in the Pandas. So pd dot is telling us, look, this is from the Pandas package, and then pivot table. So the Pandas, you can see here, is a package providing fast, flexible, and expressive data structures, and so on, main features. And you can read that through maybe yourselves. But what are we doing? We're saying take the titanic3 dataset, which is now this, and break it apart for the sex of the passengers. So, and even though we're not making explicit here, we're going to get the mean values. So females and males, females had a mean age of 28.57, a mean fare of 50.15 for all 3 classes. Parents, children, 0.66, which is kind of nonsensical. Sibling, spouse. So these are just averaged out, and then survived. 75% of the females survived, whereas only 20% of the males survived. And the age, males a bit older here, the fare a good bit lower. The average fare is a lot lower compared to the females. And remember, we had first, second, and third class here, and so on. Parents and child, sibling, spouse. So probably more unaccompanied males, right? Perhaps, right? That's one way of looking at this. So there may have been a lot of males, economic migrants in the early 20s, who were emigrating from Europe to possibly the US, right? Okay, now we can graph that out and it provides something. Let me just see, that didn't in this sense. So let's run again. And we have table and table plot kind. Okay, and our graph now is working, right? So again, we can provide some graphing potential here for our tables. Obviously, the parch and sib is so small, we don't really see it here, or survive, the percentage surviving. So we could exclude these and then do the table. It's really depends on how we set it up. Okay, now just a note, if I had made explicit, these are actually means. How can I show that? We can make explicit what it is we wanted calculated in this table. I'll just remove this for a second. And we show that, okay, we want to estimate the mean of each of the cells. Let's execute. And of course, this table is exactly equal to the table above because these are means, even though it wasn't explicitly alluded to, it's implicit. Okay, but we could get the median, and that could be more informative in some respects because it's giving us typical. And so the typical age was 27 for females. The typical age for males was 28. The fare was typically 26. So obviously there's some skew here. There's a few outliers who paid exorbitant fares, but males 13. Again, there's quite a disparity. The men typically paid half of what women were paying. And then in terms of parents and children, more often than not, there was no parent, children, or sibling spouse. And women typically survived, males typically drowned. Okay, so median can be quite a nice way of looking at this. Now we could do minimum as well, just to put it in here for completeness. And NP min, let's run again. Now in this case, it's not working. Let's see. Mean is working. Okay, and median. Okay, so median works. Later on, I'll show how to put in mean, min, and maximum. Looks like for the moment that's not working. Tables we can plot out, and of course it probably looks we're getting some semblance here. So when we're looking at the females and the males, we can plot out with a bar chart what's going on. Okay, now we had initially started with sex, but we could make the index have two columns, right? So we could say, okay, females and males, but then for specific points of embarkation, right? So we want to look at the female and the male, and we're going to take, we can take the median, perhaps, maybe I did that below. Well, the mean we did below. But if I just use this syntax, PD, pivot, titanic3, sex, embarked, then you can see I have the females and the males. And then for each location, that each port, that point of departure. And then for each of those, we have, it will be a mean fare, a mean number of parents, children, siblings, so on. and we can run that again. And you can see the numbers here tally with the numbers above. So it is defaulting to mean. And if we do median, it might be more immediately revealing. So for instance, typically those who boarded in Cherbourg survived, who are female survived, who boarded as females in Queenstown. It looks like they didn't survive. Southampton, they survived. So it looks like females boarding from Queenstown did worse than the other two groups, right? The ages, a little bit older, Cherbourg, and Southampton, a little bit younger, Queenstown. So again, probably a lot of economic migrants. And the fare here was typically very low for females and for males, not much of a difference. And the male typical age is 30. Which again, so it looks like a lot of young females, right? And then Cherbourg 30 and Southampton 28. So again, it's interesting when we run through the pivot tables, something new always appears and always a little bit revealing. So the pivot tables are very powerful in terms of putting together insights into what was going on. And we tend to agonize over them a little bit more, maybe to give us a true sense of underlying trends. Okay, and works very well. If we're doing machine learning, sometimes we need to hone in on particular categories that can be summarized into pivot tables, and that then reveals to us something that maybe you just wouldn't see from testing the accuracy of a machine learning model. Okay, now we can do the same again, but this time we're going to say, look, age, I want the mean of age and I want the sum of the survived. And we're just going to, in our, again, we have, well, in this case, we have sex and in PClass. We could change this to, again, to embarked, right? Embarked. So basically, to make the comparison, we'll get the sex and the point of departure, and then we'll get the mean age, but the sum of the survived. Okay, so it's what we're getting here is the age. So we basically have this a table constructed in a very similar fashion to what's above, but we're using the mean for age and the sum for survived. Again, if I change the mean here to median, right, we'll reproduce what's above here. So let's do that. Let's go median. And then for survived, let's go median as well. And just execute. And basically, we'll replicate what's above, but we don't have here fair parts and sibling. We weren't interested, so you can see we can target in on a specific set of columns that we want to introduce into our pivot table. So we don't need very large pivot tables. Sometimes the smaller they are, the more immediately or the more quickly it's easy to delete something from the table. Okay, now again, we could go with sex, PClass, value survived. Let's take a look at that. And we're going to take the mean value of survived. And we could change that to median and execute. And we have here. We can also introduce, just to complete this, maybe we'll set out, it might be useful to set out a column. So let's do that. Let's introduce another snippet of code here. And we'll just fill out a little bit more the syntax available to us in the PD pivot And then maybe if we have a more extensive data set, just write it out and then download to Excel. So I'll go get some code to run that. Okay, so here we're using more fully than the syntax available in the pivot table function. So we're going to read in, create an object again, a new object table, and we're going to read the Titanic dataset, and then on our axis, on our indices here, we're going to have sex and PClass like what we had before, but across in terms of columns, we're going to have 3 columns, and in there we're going to have the Southampton, Cherbourg, and Queenstown, and then we're going to get the value of the fare, and we're going to go with the minimum. Maybe we'll go with the median, just to get that working. Start off with. Okay, so let's execute that. Take a look at our table. So what we're getting here is for females in first class, Cherbourg, the median fare was 83.15. This is pound sterling. From Queenstown, 90 for first class females and 79 for Southampton. And then for second class, we have 27 for Cherbourg, 12 for Queenstown, 23 from Southampton, and for third class female, 14.45 from Cherbourg, 7.75 from Queenstown, and 12.28. Right, and again, when we come below here, you can see something similar. The Southampton third class females were paying a good bit more than the females, and from Cherbourg, third class females are paying a good bit more than third class males. But interestingly, the median typical fare here from third class from Queenstown is the same males and females. That's true for males and females from Queenstown in first class and in second class. Again, I haven't seen this before, and it strikes me as a little bit odd, because if we look at the female in first class, they pay a lot more than the male here. Second class from Cherbourg, they're paying a lot more than the male counterparts. And the third class females were paying a lot more than third class males. Again, striking me that this is not completely comparable to what we have here. The trend here, the median fare was the same. Now, if we change to mean, maybe we get a different pattern emerging. Right, let's just run that, see what happens. In fact, the mean fare here in third class is 13 for the males and 12. So by and large, I think let's check again, it's interesting in its own right, but the only exception here is the males are paying more than the females. But everywhere else, the females are paying a lot more than their male counterparts, it would appear. Female in first class, Southampton paid 103, while the males paid 57. Again, I don't know why that's the case. It's my curiosity is aroused. Let's take the minimum fare for males, 675, and males 968. So there was a very cheap fare. In fact, from Southampton, there was a fare even of 0. And again, I'm not sure what's going on there. Maybe the fare wasn't properly recorded. That could be one possibility. What about the maximum fare? Let's execute that and run. 263. First class was the maximum fare. 90. I think there was only 2 passengers who went in first class from Queenstown anyway. So we're getting the same median, mean, maximum, min for those fares, but it's only because there's a single passenger in each. But from Cherbourg, 512, and male and female the same. 4157, 4157 second class, right, and 18. The maximum fare in third class was 19 and 18. And the maximum fare in third class in Queenstown was 29, which looks out of kilter with the second class. Right, so some anomalous behavior. Why pay more for third class compared to second class? And the pricing is fascinating here. The fares are really some curiosities. Females typically are paying more than their male counterparts, but there are a few exceptions. And then when you compare the medians, the means, the maximums and the mins, we're getting something different. If we put in sum here, we might get the total revenue being generated. So Cherbourg first class is generating a lot of the revenue, right? So we're taking the sum of all the fares. Probably if we leave out PClass, if we leave out sex for a moment and just run, we can look at first, second, and third class. Cherbourg compared to Queenstown, compared to Southampton. Cherbourg, a lot of the fares are coming in Cherbourg compared to Southampton. But then second class, a lot of passengers must have got on in second class in Southampton. And in third class, Southampton, a lot of fares. And Queenstown is providing some revenue, but only a bit. So we might ask, is the calling to Queenstown, maybe it was important because it was the last port when leaving Europe getting to United States. So maybe there was some refueling or food or something also being provided in Queenstown, maybe some cargo or something. I'm not sure. I think it's the passenger ships, possibly not cargo, but maybe food supplies or something also being provided in Queenstown. Again, the fares are very interesting, and we can see they're interesting because it provides us a little bit of what's the economic engine here, right? And there's another way of looking at the Titanic data set. Okay, so a lot of pivot tabling there. There's obviously scope for more, but I'm going to leave it here.